Hello, I'm Pete Line. I'm the founder of reInvent. reInvent's a media company that is really on a mission to find top-tier innovators who are out there trying to figure out how to solve the big challenges of our time, and also how to think through how would we fundamentally reinvent the systems of the 21st century to deal with those kind of challenges. We do this through a variety of ways over the last 5 years as we've been building out. We do it through large-scale bringing people together in events. We do it in roundtables with half a dozen folks or so, and we do it in deep dive interviews with folks that really are pushing the frontiers of what's possible. And today we've got one of those folks here in the form of Brian Sager. Brian is the co-founder and CEO of Augmented, which we'll talk about soon, but think of it as a kind of a next generation search tool that allows you to connect up people from all different fields who are working on similar problems and all different information in siloed kind of places all over the kind of internet and all kinds of different databases to kind of connect those things up in ways that frankly will accelerate innovation. We're going to talk about what Augmented does, but before we get there, we're going to basically talk about the big picture of what the world's up against right now, what are the big challenges, and ultimately why something like a tool like Augmented could help. So Brian, thank you for coming into the studios here in the Mission.
Thank you.
So just to kind of put that framework, I know you for many years here now, in fact, previous companies you founded and run, but when you really step back in the big picture, what's going on in the world right now, it seems to me a lot of folks are extremely worried about all the kind of challenges we're facing simultaneously. And I'm assuming, do you kind of share the sense of kind of urgency about what we're up against right now?
Well, there's certainly a large number of problems in the world. The exciting part of that, though, is that many of them are very likely solvable today if only the right people knew each other, if only they were connected to each other. And the challenge that we all face is that most of us find our information in a kind of serendipitous way. Might be a chance encounter at a dinner party or in a church or in a bar or a conference, academic setting, industrial meeting. And there's roughly 200 million knowledge workers in the world out of 7 billion plus people. Those 200 million knowledge workers cannot meet each other in that way. There's just too many of them. They can't find each other in a social setting because the physics of that don't work. The social physics fail, right? So how do you have a dinner party for 200 million people? So that's the challenge. How can we socially engineer people's capacity to find one another through their shared ideas in a way that doesn't require them to scan through all the knowledge in the world?
So there's two challenges basically. What you're saying is we face all these challenges, climate change issues, the breakdown of 20th century economic systems, all the different things that are starting to tear apart the framework of the old 20th century kind of systems. And although people see that as big challenges, what you're pointing out correctly is that there's all kinds of ways to solve these things and re-stitch together more 21st century systems that would solve that. But what you're saying, one of the big challenges is the people who actually could do that don't know about each other at some level.
Right.
And so there's one thing we're trying to wrestle with is how do you get the right people together to solve these solvable problems? Would that be the one way to think of it?
That would be extremely accurate. Let me give you a very apropos example, which would be genomic privacy. So there's a lot of geneticists who have been trained in life sciences, educational settings, who are socialized into networks of other life scientists. They understand genetics, they understand genomics, and they understand the need to have privacy with certain kinds of biological information that would be highly personal. On the other hand, you've also got a lot of attorneys who may have studied constitutional law and looked at privacy from the perspective of a founder's framework, where when they're in that time frame, someone might be just rifling through someone else's desk to look for a particular paper document. So it doesn't scale to the level of genomics. And we have technologies like personal genomics that are on the horizon that are scaling up very rapidly. We don't have the legal infrastructure surrounding that. So how do the attorneys meet the geneticists? How do the geneticists meet the attorneys? Some academic institutions have folks that are trying to cross those barriers and forming multidisciplinary institutes. Some companies deal with this as they interact with their customers and partners and investors, and they have to think through the legal issues surrounding all of these transactions as they build longer-term relationships. But in all of these cases, this very random kind of social interactions are driving a lot of this integration. yet the need to move at a much greater pace is really apparent. So you have experts that are highly siloed, highly compartmentalized, precisely because they're specialists in the kind of knowledge that they've been trained in. That is their strength, and it's also their weakness. So how do we take the weakness and turn it into a strength?
Totally interesting. Okay, so meanwhile, you have these people, these experts in these different fields who don't know of each other, but would be great synergistically connecting. Meanwhile, we've got, the mushrooming kind of piles of data and information and papers and things like that, that essentially, if you were going to start to solve all these big 21st century challenges, you'd want to know, well, what's out there, what's already known. Don't reinvent the wheel, but let's connect this stuff up. So talk to us about the challenge of essentially just understanding the actual breakthroughs, ideas, new papers, new ideas that are actually out there right now. Tell us about that challenge, which just seems to be quite huge.
Sure. Well, the fundamental challenge is that we're all human beings, and we're all constrained by our human condition in that we have to sleep, we have to eat, we need to talk to each other. We can't spend all of our time reading. So that's the human condition. And then at the same time, there are more than 10,000 scientific papers that are published every day.
Every day?
Every day.
10,000 scientific papers.
Just in English, just in peer-reviewed journals. If you add non-English journals and non-peer-reviewed content, it probably doubles. Beyond that, you also have, for example, let's continue with the genomic privacy concept. In the legal side, 5,000 patents issuing every week around the world from different global patent agencies. Numerous legal cases and case law are being developed on the scale of hundreds to thousands of cases a week. News articles from top tier kind of media outlets on the scale of thousands of articles each day. So if you think about this, it's impossible to keep up. And even folks who have deep expertise in a certain field could spend all of their time reading, and they would fall further and further behind. There's two fundamental results or kind of inevitable conclusions that come from this kind of constraint. The first is that even people who are deeply expert in a particular area have a harder and harder time not only keeping up within their field of expertise, but also crossing over the fence to look at other content. Yet most of the innovations that we see come from interdisciplinary interconnections. So the fence sitters, which are so rare, are the essential medium by which innovation occurs. So that's the first challenge that comes from this massive growth of knowledge. The second is that the way we have historically led one another through the knowledge trails is through citations and references, links, shared URLs, and so forth. And in all that kind of content, the presupposition is that the author knows what to connect to. But the author is also a human being, and she or he cannot keep up. And if they can't keep up, they can't cite what they don't know. And so the citation network is invisibly crumbling. It's becoming sparser and sparser. It's as though you were in a forest with some peanuts you were following from somebody else's trail, and that peanut trail ends, or it splits into 6 directions, and some of them end. What do you do? So a lot of folks, when they're thinking about this, they think from a confirmation bias perspective that they have solved whatever issue they need because they've looked in content in traditional kind of knowledge discovery processes. But when you're dealing with a very sparse citation network, most of the links they would follow, the citations they would track or monitor, are simply missing. So that if you'd like to take a guess, or I can tell you how bad the situation is, if you had 100 documents that were highly interconnected to each other because they shared deep meaning, 100 documents connected together because they shared deep meaning, what fraction of those documents actually know about one another? I mean that in the sense that the author could cite other content that's highly relevant.
At a 30% or something.
So a lot of people guess in that range, and it's actually quite low. It's 0.1%.
0.1%.
It's 0.1%. And we've looked across case law, patents, scientific articles, several fields where there's a lot of self-referencing within that field. So for patents, we've looked at prior patents, prior art, as they call it. In the scientific domain, we've looked at the reference section of scientific articles to see who cited who. And what we've seen a disturbing trend as well, which is tribalism. Now, the human mind has a limited capacity to remember names and faces. And through most of the past 10,000 years, the way we've self-organized has followed those biological constraints. And so you may know that there's roughly 150 people that we can remember at a time. That's why military organizations are broken into those kinds of units. That's why corporate organizational frameworks leverage those kinds of units. Certainly in a department of a university, there's generally fewer than that in the department from the perspective of faculty and grad students and so forth that would be working there. So in all these different kinds of ways of working together, we bump up against that limit. What we see in terms of citations is that people cite who they know.
Yeah.
And they stay in that 150 or so tribal range. If you look at one paper to the next, you see the same references coming up over and over again. What that means from a math point of view is that the authors are in a local optimum. That means they know who they think they need to know, given the context that they're in right away. They're very unlikely, though, to be in a global optimum. So where they should be is not where they are. And the difference from where they are to where they should be are, to paraphrase Donald Rumsfeld, the unknown unknowns, right? The idea is that if you don't know what you're looking for, you can't find it. And so as these 10,000 scientific papers, thousands of legal cases, patents, all kinds of different news, databases that are containing content that are unstructured text from, say, clinical trials, all kinds of literature that would be published in any format, technical white papers. All of this content is disconnected. And it's only connected through tribalism to the scale of maybe 150 other people at most. So everybody is in this constrained universe, and yet the problems that we need to solve require transcending those constraints.
Totally get it. That's really interesting. So let me just step back here. And so the bigger picture, what we're facing here is we have this constraints on how our brains could work. We're faced with this burgeoning amount, insanely burgeoning amount of data, which no human can keep up with. And we are essentially trapped in these silos of kind of tribal silos, but also field silos, at a time when we really need to accelerate innovation. And to truly accelerate innovation, you'd want to connect up everyone who knows something about some field or some problem or some kind of area, and you'd want to understand everything that's relevant as quickly as you could about what's already been done in that field, those two pieces. And yet no human brain can do that. So this is where you enter with this challenge of needing essentially a new generation of tools.
Right.
And that's what's interesting is you guys are onto this. And so let's start to shift this a little bit into how could these tools start to help us solve that problem with the ultimate goal of solving the big challenges of getting more human innovation going behind it, right?
Right.
So when someone outside kind of the your area of just says, hey, well we got Google. We got these ways, we're all interconnected through the internet and we got all this information connected. Why isn't the existing search engines able to help us solve this problem? Can you explain that to someone?
Sure. Well, first of all, Google's fantastic. I use it 50 times a day at least. Everyone I know uses it constantly. So it's a wonderful tool. It is very different than what Augmented does, in that it scrapes the web, and Augmented doesn't scrape the web. And it interconnects documents based on links, and Augmented connects based on unstructured text. So,
which we'll get into in a minute.
Which we'll get into in a minute. But for conventional search, there are relatively few documents on the web that are deep quality, sufficiently long to be meaningful. So we actually did a little survey. We looked at the top 1,000 websites as ranked by Alexa, and for each of those websites, we downloaded the number of documents that were publicly available, and we counted them up. And on the top 1,000 websites, we had 1.3 million documents. 1.2 million of them came from answers.com, and they were generally focused on very pragmatic issues like how do I clean my pot or something like that. And there may be a paragraph of text around that. So if you subtract those out as the kinds of high quality content that we're looking to interconnect, you're left with about 100,000 documents, right?
On the open web.
On the
anyone
open
can
web
do.
and the top 1,000 web. I'm not talking about portals, but actual websites that are specific to a particular knowledge domain. So of those 1,000 or so, that means that there's roughly 100 documents per website, and that corresponds with at least my own experience, where I might see white papers, technical papers, brochures. But that's a very tiny amount of content relative to what's out there in the world. We're in an era of zettabyte scale knowledge growth. So, having 100 papers per website just tells you how little is on there. So I view the World Wide Web as an incredibly important and useful tool, but it's a very weak scaffolding of knowledge, because first of all, the authors can't cite what they don't know, so they can't refer. So the citation network being 1/10%, which by the way crosses all knowledge domains that we've looked at, because it's about the human condition, not about the content. In all those situations, you can't use standard tools to find information where the authors didn't know about it already. So there's two opportunities here, and they're also flip sides of the same coin on the human condition. On the one hand, we need to respect the fact that we can't know everything and find everything just by ourselves. On the other hand, we also have to realize that computers are not very good at creativity or innovation. They're fantastic to classify content, but they're an augmentation to human imagination. So we need to respect the fact that we can't do everything a computer can do, but we also need to respect the fact that a computer can't do everything that we can do, and we need to combine those together. And that combination, I think, not just within my company, but in general, is becoming more and more obvious to a lot of folks. And that is, a broad framework of augmented reality, augmented innovation, where you're using a computer to do processing at massive scale that your human brain can't perform. But once that's done, you have judgment that the computer can't perform. You have the capacity to leap across different areas of knowledge that even the most sophisticated supercomputer cannot yet do.
So just given, you haven't even used the word artificial intelligence or AI yet, but basically, just again to step back into the bigger picture, what you're describing here is, here we're at this era of, we've got increasingly sophisticated artificial intelligence, and we've also got this limits on what humans can do. But what you're pointing out is that marrying these two together is this kind of potent combo, that the best of the computer world and machine learning can do things that the humans can't: scan billions of documents at the same time and find relevant connections. At the same time, the computers can't do what human brains are essentially optimized for, which is innovating, creating, kind of pushing into unknown spaces, imagination, things that actually connect dots that aren't necessarily rationally connected, things like that. Is that the good way to think about it?
Absolutely, yeah. If you think about classical machine learning, one of the first things folks learn how to do is to take a certain image, and the standard example is a bunch of cats. How can you define a cat by its features, image-wise, from other objects? And you can develop an exquisitely sensitive algorithm to do that, but it's not a reflection of the kind of judgment that a human would have. But if you were to ask, is this cat related to some other creature? Could you crossbreed this cat with, say, a lion or a tiger? There's no way for a machine to make that assessment. So something that a child would understand, small child, even the most sophisticated computer may not. So there's nothing wrong with that. Machine learning is wonderful, but it's not going to create sentient robots that are going to take over the world anytime soon. What it will do is allow us to massively process data, but then the question becomes, what are we processing it for? Now, computers can generalize, and that is the basis of artificial intelligence. If you can't generalize, the system isn't very valuable, but the systems that people have developed generally can generalize, and because of that, the industrial applications are immense, yet they are insufficient for ideation, innovation, and interdisciplinary creativity, that spark across a field, the jumping over the fence, computers don't do. So the idea is, how close can we bump up against where humans are helpful, which is in that creative way of thinking, but leverage the computer to do things that humans can't, which would be process huge amounts of data.
So back to that analogy to Google. Google is awesome at essentially one, scouring the web, which is a limited amount of data that's available to human beings. That's one limitation you said. But the second point is it's good at finding one specific piece of information that might match your criteria to get that one thing you're looking for. The needle in a haystack thing it's awesome at. But what you're setting up as a challenge that's different is you don't want that one needle, you want to know what are the most relevant, all kinds of different relationships of data that you don't know about, and also the people who are clustering around the top end of that field of understanding what's going on. Is that maybe one way to think about it?
Yeah, I mean,
distinguish to someone outside what is the challenge, the data challenge that you're trying to solve with Augmented, and then talk a little bit about how you do that.
Sure. Well, with Google as a baseline, the system has historically been based on links from one website to another, and using an academic citation factor type metric, which was originally called PageRank. And the goal in that era, which is still being used by many different companies, is whichever website has the most links into it is a proxy for validity. And with that proxy for validity, people would promote that content which has the most links to the top of some search. And so you would generally get higher quality content. The challenge there is, first of all, in the keywords systems that are used. Google only enables 32 words in a search. And many people, most people, don't use that limit. They'll go to 3 or 4 words at most. And so they've been trained, and I would argue almost insidiously trained, to put in keywords that they know they'll get results for. So because Google's so useful and effective in what it does, people have done many searches. Some of them have failed, and they've said, well, I can't use that combination of keywords. That's not going to get me what I want. So how will I get results, right? Mm-hmm. And that works really well to get you to a local optimum. But if you're trying to get to that global optimum, the top of the mountain, instead of being on a mountain that's, say, less than the top, let's say we're in the Himalayas, mm-hmm. you're halfway up and you're cheering because you've gotten to the top, and then you look up, oh, wow, there's another mountain that's 10,000 feet higher next to me. That's what I mean by the global optimum. Mm-hmm. If you don't know what to look for, you can't find it. And so we view keywords as poisonous in knowledge discovery because they presuppose the answer to the question, and then they, through a form of confirmation bias, validate that. But the reality is our thoughts are not so well defined by 3 words. If you think about any relationship you have to a person, an idea, a historical trend, usually 2 or 3 words is insufficient to capture the nuances and subtlety of any of these kinds of topical themes. So our approach has been to do whole document queries where you just drag and drop an entire document. If there's 10,000 words on it, we search on 10,000 words or more. And it's the social equivalent of 2 people from different fields sitting across the table at some intimate dinner party and discovering all kinds of connections they never knew they had with one another. And they leave very excited because they found this kindred spirit, this colleague in some other field that is highly relevant to what they're doing. That's where most of the innovation has happened over the last 100 years. It's been because people, or ever probably. I'm going to guess
the salons in Paris and the
yes.
Enlightenment or whatever
yes.
it was. It's always these connection things.
Yeah, the Medici Effect, the Parisian salons, for the Roman engineers, the Egyptians. It goes back quite a long time. But in all of these situations, how big could the salon be, right? You can't have a salon for 200 million people in the streets of Paris or a dinner party that way. So we have, not only do we have not enough time to process information, we also don't live long enough to meet everybody because the world's population is growing, which is, of course, one of the problems. But it's also one of the solutions because a certain fraction of those people are knowledge workers that will solve these problems. But they need to find each other. The companies need to find each other. The innovators need to find each other. The people who are commentators in society need to find each other in all different kinds of ways. And they think they can right now, and it is a Wizard of Oz scenario. And what we're trying to do is pull back the curtain and show there is no wizard. In other words, the use of a citation network to connect knowledge is too sparse. To do this manually doesn't work because you can't meet everybody.
Yeah.
If you use traditional feature extraction, which is a central aspect of machine learning, you have to supervise that feature extraction learning process on a static data set. But if you've got an exponentially growing pool of knowledge, you can't train in that static way and have anything other than an obsolete model when you finish. Because the moment you finish, the amount of information is increased.
So just meaning if you had a static database, you could essentially create algorithms or program it to actually thoroughly suss out what that is. But what you're saying is, while you're doing that, there's 17 other databases that's just emerging and that you have to rush off to them. Is that what you're trying to say?
That's one key challenge. And the other key challenge is just programming for innovation is not something a computer does very well. Like, you can't say create, innovate, have this crazy idea. I'll give you a really interesting example of that. So Kary Mullis, who won the Nobel Prize in Chemistry in 1993 for inventing polymerase chain reaction, he is one of the foremost innovators in biotech. But the reason that entire chain of technology was created, when he was working at CETUS, which is in the East Bay, there were layoffs that were going on. And he was going to lose some lab techs in his lab. And he was trying to protect their jobs to help them. And that was a motivation. He also had all these oligonucleotides, which are chemical reagents essentially, in his freezers. He was trying to think, what can I do with those, right? So computers don't think that way. And he's driving down the freeway, I think going up 101, some late night, and he suddenly realizes that he could separate DNA strands by heat and use heat-resistant enzymes to duplicate those strands while they're in their single-strand format, and do that in a cycle over and over again, and create from a very small amount of DNA a large amount of identical DNA. And that has had an enormous impact on the world.
And did he win the Nobel?
He did win the Nobel in '93 for that. And I've talked to him about, his innovation process. And it was combining the business need of keeping his technicians, just his empathy and compassion for his employees, plus extra reagents in the freezer, plus thinking through the mathematics of self-amplification. And all this just kind of came together.
But didn't he, I think didn't he also have some stimulation through some kind of, I think it was some kind of drug, right, that he was also kind of tripping out on when he thought about that?
He probably was, yeah.
I think that's publicly been talked about, actually.
Yeah, he smokes a lot of cannabis, which is, of course, legal now in California.
Yeah.
So, but I think for him, beyond any kind of stimulant like that, if you think about what that does.
I'm just saying,
Well, but let's use cannabis as it's a great example. Cannabis disassociates ideas and lets them reassociate in kind of random ways, in very short-term ways. So you can have an innovative thought that's with you for a few seconds and then it's just gone. So if you're writing it down, or recording yourself, you'd be able to maintain that. So some people do that kind of work. Let's go back 100,000 years. When did our kind of pre-Homo sapiens species really start to innovate? It's when our cerebral cortex, from a cultural anthropology lens, grew enough to allow free association of ideas. So we literally grew the circuitry 100,000 years ago to deep associate. And what this cannabis example is also a kind of reassociation and then a deep reconnection of ideas. So it's this idea soup that we're trying to spin. And computers are just not quite there yet. There's two schools of thought in AI. One school of thought is, and this is from some of the originators of backpropagation, like Geoffrey Hinton and others, who strongly feel that the algorithms that exist today are sufficient to push us forward into the future, and that some of the elements of those, like stochastic descent gradients, will basically have an unlimited future. There's another school of thought that says there's a limit to what machine learning can do in the way it's being developed right now by most folks. And we need to circle back to more traditional or conventional algorithms from the 1970s and 80s, and that synthesis will allow us to move forward. So there's argument in the field, and I wouldn't pick a side. I think they're both right and they're both wrong, probably at the same time. because things are never that clear. Everything's in the gray zone. But I do think that the human brain is, right now, the best creator of novel thoughts, whether induced by a drug, induced by exhaustion. A lot of folks have their best ideas, including me, when I'm totally sleep deprived.
Yeah.
And I don't know why that is, but I know several other people who, express that feeling too.
Yeah.
So there's some kind of edge state of our neurophysiology that lets us free associate. And when that started 100,000 years ago, that really amped up our capacity for language and tool making and innovation, and that hasn't stopped. I mean, 100,000 years is a blink in time and from a geological perspective. So this was kind of instant before us today at that scale. So if you think about using a computer, the idea there is the best thing a computer can do is process a well-structured algorithm incredibly fast, incredibly parallel. And so it's great to do like initial classifications of content, but finding the interconnections between them has been challenging. So what Augmented does, we fuse machine learning with graph mathematics and natural language processing and something we call linguistic blockchain. And all of those together enable us to accelerate innovation. And so there's two fundamental uses of Augmented from just a very humanistic perspective. One is to get smart fast in a topic and learn about the schools of thought and the collisions between folks who are doing work in the same area, even if they don't know about one another. And then the other piece of that is to be able to innovate across different fields with extreme boldness, fearlessly innovate across fields. And that implies knowing what's out there. So you need a starting point and an ending point. And how do you bridge that gap? Well, you bridge it through unstructured interconnections that self-assemble. And so the self-assembly process is what's critical. And by self-assembly, I mean we don't presuppose a taxonomy or an ontology or some way of labeling the information. The way I think about the information overload, it's a wonderful problem we have because there's so much productivity and knowledge in the world. But if you use the metaphor of water and say all that knowledge is water, and a knowledge discovery system is a dam, and there's a hole in the dam, and the dam's purpose, let's say, is to organize that water, right? If you put your finger in that hole, which is the metaphor of stopping the flow of knowledge until you can organize it, it's futile, right? If you're sticking your finger in a dam with 100 million gallons of water behind it and you're trying to stop it, that's the equivalent of building an ontology or taxonomy for knowledge where ideas could come from anywhere. They're already highly fragmented. So a lot of work has been done, and I'm not going to name names, but in the 70s, 80s, and even into the 90s where people were trying to force organizational structure on a scale of organization they could not control. And the futility of that, there's a lot of brave people who've tried to manually index huge amounts of content. Now we absorb those databases into Augmented, so we thank them for that work, but there's no way that can scale. And even if you think about the way the internet indexing as an analogy, again, we're not scraping the web, but go back to Dave and Jerry's Guide to the World Wide Web. That was the precursor of Yahoo, right? And it was on the Akabono server at Stanford at the time. They hired hundreds of people to create a taxonomy of websites. And if you remember that, so you're like looking at a hierarchy and you're thinking, why is that hierarchy the way it is? It could be many other ways too. That happens to be the historical legacy of whoever created that structure. But then you go through sublayer, 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 sublayer. That kind of worked when the web was in its infancy, and we're talking, say, 1995.
Yeah, mid-90s.
But now, in this era, the idea of like organizing all the content on the web even into knowledge domains that are very specific in kind of a 19th century way, the way, say, a biologist would do this, as they're studying species in a forest, trying to organize the birds against the insects, against the mammals, against the trees. That doesn't work. Knowledge can come from anywhere, and the interconnection of it could come in any way. It's a super high dimensional space. So rather than sticking our finger in the dike or the dam and trying to stop 100 million gallons of water, in other words, manually organizing massive amounts of information, or forcing a taxonomy that is extremely arbitrary and stale the moment it's created, I think a current century approach would be let the water flow.
Yeah.
And instead of trying to block it so you can organize it, let it self-assemble
Yeah.
without the need for human intermediation. And when it self-assembles, it scales.
So I love that idea. And so what you're saying, what your tool is doing is taking that body of water, stripping out, analyzing all the document, everything in those documents, or whatever it is, stripping out useless words or redundant words or the and us and all these things that really aren't going to help you anyways, and boiling and essentially getting it down to like the relevant words that says, oh, this is something about genomics, patent law or something. That is also boiled down those same words that would be dealing with that same thing in another field. And you just connect those dots for humans to look at and say, oh, wow, I didn't realize that there was this going on here and that going on there. Let's bring those people together, or let's build off that base of what we already know to start innovating in a new space. Is that a safe way to kind of say it?
Yes, and if I can put my linguistic hat on for a moment, restating what you just said from a computational linguistic perspective, there's 3 general categories of words, right? Verbs, adjectives, and nouns. The verbs that we have are reused in many different purposes, for many different purposes. And because of that, they're not very helpful to connect documents together. Adjectives are also highly interoperable between different ideas or topics. And there's a lot of slang and metaphor and idiom associated with both verbs and adjectives. So when you get to the nouns, especially rare specialist nouns, you get to strong and discrete semantic signals, so rare words, especially nouns. When you connect documents together using rare words such as nouns and not focusing on verbs or even adjectives, you don't need grammar anymore, which means you don't need machine translation. And machine translation, although it's dramatically improved in the past 10 years, has historically been challenging. So the way Augmented works, for example, is we work in mathematical modes. So we take the rare nouns and create mathematical equations. Then we connect to other documents that have similar mathematical equations. So if one document's in Chinese and another's in Farsi and another's in German and others in English, we will connect them together because they're on the same topic without having to worry about the nuances of grammar or kind of linguistic expression in the native language of that document. So this is basically a reversal of the Tower of Babel from a more biblical point of view, right? What we're trying to do is cross all languages, cross all knowledge domains, and create a centralized index of knowledge, which is what Augmented is named for, the state of everything, connecting everything together. Now to do that, there's a lot of noise that one has to deal with. There are certain kinds of words that are exactly spelled the same way and sound the same way, that are used very differently. I'll give one example, the word administration. In finance, the word administration means to manage information and people for some kind of outcome, right? To administer a process. In medicine, the word administration means to deploy a drug to a patient. And so if you see that word administration between these knowledge domains, it's a false positive because the word is being used in a very different context. So we had to deal with finding many false positives between many fields. On the other hand, people can use synonyms or even completely different words that are not synonymous or sets of words to mean the same thing. And so those are false negatives. So we want to get rid of the false negatives. We want to minimize the false positives as we interconnect documents across many knowledge domains. That was a very important and incredibly difficult piece of what we were doing. So in Pharma, we had a customer that was trying to cross the blood-brain barrier. The blood-brain barrier is a membrane around our brain that keeps large molecules out intentionally. We've evolved. So there's bouncers basically at every door that say, you're a big molecule, stay out, right? Small molecule, come on in, right? Well, Pharma's been trying to have big molecules come in for the past century. Those are drugs that we use for medicinal purposes. but they get stuck at the door and the bouncer says, go away, right? So how do we cross the blood-brain barrier? So one of the things that one of our customers did is they dropped in a large document, maybe it was 30 pages of text about the blood-brain barrier and the history of the blood-brain barrier research, how to try to get through that membrane for the last 100 years. So very complex idea. Mm-hmm. So the closest idea came from battery technology. And in a battery, you have a semi-permeable membrane, which is storing energy across a voltage gradient. Mm-hmm. And so in that area, they were trying to figure out how to make pores wider or smaller. So the pore widening chemistry would let in larger molecules. Does that sound familiar, right? Mm-hmm. So the length scale and the time scale and the temperature scale and the kind of chemistry were all similar enough that the people in this pharma neuroscience division were inspired by this kind of renewable energy sub-area. That is an idea that, I, for example, who've been in both neuroscience and renewable energy, I never would have thought of it.
In fact, you've had companies in both, you've had a company in one that you've co-founded, and you started your career in the other one, right?
Right.
And you have, I think, an advanced degrees in bioscience, right?
Yeah.
So you never thought of it.
Yeah.
But here this connection happened, boom.
Yeah.
And now they're running with it.
Yeah. And so that's the idea. So they were the stimulus for the query, which is how can we cross this membrane with bigger pores?
So this is exciting. This is exactly, and it's a good example. And I think it's worth saying here. I mean, we've been talking about, if you were just sitting here as some academics thinking, wow, wouldn't that be cool if we did that? But you actually have a company. It's well funded with venture backing. You've got advisory board of kind of leading figures. You've got paying customers from all these leading kind of fields. And you're at a juncture now that, what? How would you explain where you're at? You're ready to scale. You think there's more to do here. I mean, frame a little bit about where you're at in your journey.
Yes and yes. So our fundamental R&D, which took several years of deep stealth, is done. Product works really well in the areas of knowledge where rare words are common. So will never be useful, I think, to look at tweets with common words or acronyms that are just, like BFF and LOL and stuff like that. It's just mathematically too sparse a set of content. Mm-hmm. But where we have succeeded in a major way is in the area of technical literature, clinical trials, scientific papers, legal cases, financial documents. So where rare words are the norm. And the rarer the word, the better, and the longer the document, the better. Mm-hmm. So in this deep tech, kind of deep information content regime, that's where we can help the most. And that fundamental R&D is complete, and the product works great. Anybody can try it out. Where we need to do more is ingest more documents. Mm-hmm. So we have one of the largest databases in the world, I believe. It's a database of databases. We pull out entire data sets or repositories from, for example, the FDA, the CDC, NIH, NSF, DARPA, DOD, DOE, SEC, many three-letter agencies. Mm-hmm. And that's great. Mm-hmm. But even one company may have 10,000 times more data than everything in a federal department. Mm-hmm. So there's massive knowledge asymmetry in the favor of the private sector. Mm-hmm. And there's a lot of information from other countries and other languages. And we want to ingest as much of the public content as we can because there's an inherent information synergy. If we're connecting one idea to another idea, and we're trying to do this in a very high dimensional space, the more the documents, the higher the number of dimensions, the more the possible puzzle pieces can be fit together. So to find the best connection, the most surprising connection, which might be the most valuable connection, the more the documents that are in the system, the higher the probability of that success, of that surprise, even for an expert in an area. So one of the things we want to do is ingest all the public documents in the world. And that's a huge, ambitious goal. And we may never get there, but that is our intent, and that's where our focus is.
So is this, so there's that's an ambitious and awesome goal, but is this now part of you're in the beginnings stages of A coin offering, basically. Talk a little. Is this kind of related to that kind of mission piece of it?
It is.
So talk a little bit about that. What's happening there? So, or maybe just to step back a second ago. One of the key technologies that you're based this tool on. There's been AI. There's machine learning. You mentioned a bunch of them there, but one of them is you quickly said blockchain. So, given the interest in blockchain and everything else, maybe describe first just what are you doing with blockchain? How does blockchain figure into kind of your tool? And then secondarily, we'll talk a little bit about the offering.
Sure. So for blockchain, it's traditionally, if there is a tradition of blockchain, been used for financial transactions and especially avoiding double spending. So there's this classical example of Bob pays Alice $10 or the reverse, and in some cryptocurrency, and how do you know that transaction is not a duplicate and Bob's not giving many people the same $10? Well, blockchain's all about a public ledger. So you can replicate the transaction across many independent computational units, which are very difficult to hack at scale because there's so many of them and they're all storing that same transaction. So when you're in that situation with a financial transaction, blockchain makes great sense because it's an insurance policy against getting hacked, essentially. And it has evolved into other kinds of financial transactions like insurance policies and purchasing of products and so forth. But in all of these cases, there's a time-varying component, which is usually based on the value of something. And when you enter into the kind of the Ethereum-based blockchain, you have programmability of each block payload. So you could have self-executing contracts that are triggered by some environmental variable outside of that process, like the price of a stock or the passage of time, right? So that's kind of traditional blockchain. I would say 90% or maybe even 95% of the companies that are out there think of blockchain as a public ledger for financial transactions. And when they do that, they're following the footsteps of a lot of folks who've also done that. So Omni doesn't even focus at all on financial transactions. It's all about the changing context around an idea and the time variance of that idea. From the perspective of linguistic blockchain, the idea is to track the evolution of ideas through language over time. So it's not a financial measurement that's being protected and monitored. It's the evolution of the idea itself. So the semantic signatures that we've developed, the idea is to have them as part of a block payload, hashed so they don't take up too much space. But when you have an idea, it is not developed in isolation. There's a lot of other ideas that are connected to that idea, and that context may change over time. So the semantic signature may change over time. So the content in the block payload may change over time. So that lets us do several things. First of all, digital rights management from the perspective of technical literature. So we can track if the idea is separated from the author metadata. Now, sometimes that can be very benign, like a continuation in part of a patent where there's new inventors that are listed, or it could be something that's malignant, like fraud or plagiarism. So that's something we do for pure corporate hygiene, because we are ingesting a lot of documents. We don't want to ingest documents that don't have copyright clearance or that have been stolen in some way. So it's very practical for us to have this quality control filter to say, is a document that's coming in like any other document that's already there? And if it is, we flag it as something that we need to look at more carefully. So digital rights management in the context of technical language is one regime where linguistic blockchain makes good sense. Another is the flipping of that. We can actually look to see the kinds of semantic signatures that our users are querying. And when we have a sufficient aggregation of those queries mathematically, we can see the knowledge gap in the space. Everyone's looking for a certain kind of topic and they can't find it, for example. We could go to a premium publisher and say, you should generate content around this topic, whether it's a new journal or an article in an existing journal, but it becomes informing, it informs the editorial strategy of that media outlet. So that's kind of the flip side of this management.
That's interesting.
So, and then we also want to be able to protect documents that come in We use conventional cloud services, but even they generally have maybe 10, 15 or so sites. And they're generally in the same regions of the world. And we'd like to have a hyper decentralized storage of that knowledge, not on 10 or 15 sites, but on 10,000 sites.
Yeah.
So using some of the storage network companies that are in beta right now, like Filecoin or MadeSafe or Storage, there's several of them. We could partner with them to have content that comes in be distributed widely in the world, so it kind of protects. So we think of Augmented doing three fundamental things: collecting information, connecting that information, and then protecting it. Collect, connect, protect.
Oh, that's interesting.
And so blockchain's helpful in all three of those areas.
Interesting. Okay, but then brings us to you're actually beginning a coin offering in yourself. So explain that to someone who is already still trying to wrap their head around ICOs and the whole kind of thing. What are you doing? Why are you doing it? And why is it important?
So one reason we're doing it is to embrace individuals. And
Maybe explain what it is.
Okay, so we're doing a token offering, which means we're giving people a unit of consumption that they can prepay for, and that consumption unit is called a token. And what we do with that token is we enable them to do searches. They can use essentially a discovery bot in our program, which lets them run essentially a semantic clipping service. They can look through semantic space, find highly relevant documents that they would never find any other way, because we're mathematically connecting documents rather than using the citation networks. Yeah. And so those kinds of automated search processes can be used by a token. And the same thing with doing large-scale ingestion. You can upload one document at a time for no cost into Omni, but if you want to upload 10,000 or 100,000 documents, doing it one at a time is not practical. So you can use tokens to consume that process and enable. So what we do is we've granularized the consumption process. So instead of a person or a small business needing to, say, pay $1 million contract in fiat currency, which our Fortune 50 customers would do, they can buy one token at a time, which would be priced on the scale of $1, and run multiple searches on that dollar, which would be priced on the scale of pennies. So that granularization of consumption lets us embrace the small and medium businesses that we could not otherwise afford to reach, because the sales cycle would be too long and too fragmented, and the amount of money we would have as a return on that investment would be too small to be economical. But if we enable self-service, where folks can buy a token, use it whenever they want, that allows them to have access to this system. And the proceeds that we get from this will allow us to ingest a lot more documents, which will make the system more valuable from the network effect of documents being interconnected, which is discrete from the network effect of users. So we have two different network effects going on, which are multiplying against each other, and that's more information synergy. So our conventional customers in the Fortune 50, they won't procure a contract in cryptocurrency. They won't say, we'll pay this many Bitcoin or this many Ether, because that'd be a career-ending move for a procurement officer. That currency is so volatile, they have no idea what price they would be paying. So all of our large enterprise customers pay in conventional structures with US dollars. But we don't need to do that with small businesses, that we can be flexible with them. They can consume the services at $1 at a time or 10 cents at a time. They don't need to have this kind of fiat currency system, because they're procuring it in such small and granular ways. They can leverage the volatility and just wait, or if they have to pay 20 cents rather than 10 cents, it's not a big deal, right? Whereas if you have $1 million contract and it suddenly is 2 million or 20 million, that is a big deal. So it's the capacity to be scalable for small businesses and embrace self-service that's part of the reason we're doing this, while still respecting the conventional procurement structures of big companies. But the proceeds will help us ingest as much of the knowledge of the world as we can that's publicly available. The more we raise, the more we'll ingest. How much public content is out there in the world? I have no idea. I've spent 5 years trying to figure that out. But one thing I can say there's way more than any of us think. And if you think about it, all the organizational structures that would have this kind of knowledge, we have nation states. Then we have in the US states, but in other parts of the world, like in Europe and China, they have regions, right? Regional governments. And then within those regional governments within the countries, there are municipalities. And in the US, we have a county-city relationship. That's not always true in all countries. But there are 4 or 5 typically organizational scales of just government by itself. Then you think of the companies in the world, several thousand of them are global in nature, and they all have a lot of content too. And then you've got all the universities and all the advanced learning institutions and research labs and think tanks. So one of the things we're doing is we're collecting all the think tank white papers that come out of the 8,000 think tanks around the world.
And this is not already on the web, you're saying? No.
Sure, it's on the web, on each of these websites.
Yeah.
So if you want to go to Brookings Institution, for example, they have maybe 60, 70, 80,000 white papers. You can download those if you want. Maybe you can figure out how to do it in a batch process, but are you going to read that many papers to find the links? And then if you're connecting that to Heritage Foundation on the right and Center for American Progress on the left and trying to find, they also have like 60, 70, 80,000 documents, right? And then you have Chatham House and, if you just go down the list, each of these institutions has a political lens. Yeah. Even Brookings, I would say, does too. And they have different knowledge they're using. If you're trying to find truth, what is ground state truth from like a physicist perspective? It's the intersection of these common ideas. It's where everyone's in agreement, right? And then everything else is opinion by definition. If you want to know if you're dealing with a controversial idea or policy or concept, let's just use the think tanks as an example, you need them all compared apples to apples, which first of all means they need to be in one place. So that's why Omnity's doing that. We're giving this away for free. We're not charging anybody for that. What we're enabling is that apples to apples comparison mathematically of the ideas they have, and we're bringing all the content in so it truly is balanced. That's just one document source. Another example of a tragic waste of effort is a PhD thesis. Someone spends 5, 6, 7, 8, sometimes more years of their life creating a multi-100-page document that's been heavily curated by themselves, their peer review committee, the faculty advisors who are helping them. They publish this document, and it goes behind a paywall, and it's accessible through a numerical code, and you pay maybe $40, $50, $100, depending upon which country you're in, to access it. It is basically thrown in a repository, and then it's unavailable. So what we want to do is partner with the entities that have these paywalls, not to distribute around them, but to create mathematical signatures of these documents so that our partners would have found revenue, but the users would have found connectivity that they otherwise wouldn't have available. Now, some PhD thesis repositories, especially those in Europe, are online and free, and those will be the first ones we bring in. But we'd like to work with premium content publishers, including these folks, to give them more revenue, but also give the users more connectivity with no digital rights danger to them of losing that content. We wouldn't publish the document, the PhD, on Omnity. Yeah. We would just create a mathematical signature of it.
That points to it.
That points to it. And we can do this on large documents. We took Moby Dick, which is not a technical book, right? It's a work of fiction, but we put it through Omnity, and the central idea that came out was the white whale. And we didn't train it to do that. It mathematically figured out that that was what this was about. So, now we as humans know that that's a metaphor for futility, right? The computer doesn't know that. So that's that boundary of augmentation between finding the central idea, but then it's up to the human being to say, is that irony? Is it sarcasm? I mean, you can train, and there's recent evidence of convolutional neural nets at large scale to be able to detect sarcasm from trained sets of sarcastic statements, and that would lead to being able to train irony as well. But we're not quite there yet with saying, the white whale represented a futile attempt, right? So that's still a human judgment. And it's obvious to someone who's read Moby Dick what that means. But to a human, what's obvious is to a computer perhaps impenetrable right now. So,
And for the foreseeable future, I mean, you're in
Yeah.
a space where we're talking decades probably, potentially, or?
well, I mean, I'm certainly not an expert on
Yeah.
AI per se.
Yeah.
I'm just a practitioner.
Yeah.
And I've been a practitioner for 30 years.
Yeah.
But what I would say is there has to be new algorithm development or massive extension of current algorithms to get there.
Yeah.
And we're not there yet.
Yeah.
Whether a stochastic descent gradient-based algorithm is sufficient is arguable within that field. But I can tell you right now that what machine learning is great at is classification, massive parallel processing of the data that's classified, feature extraction, like what are the attributes of that data. But really having a leapfrog kind of insight from one area to another, that spark of creativity that humans have, I have never seen evidence of that in a computer. So I think we're a while away from that.
Which brings us back to where we started here, the mission. Now, again, coming off the ICO or just growing your business or however, and again, there's this publicly available way that any individual can use your set. When you think, just aside from your own product, but just think of the context of where we're at in terms of the amount of data, knowledge workers, tools, including your own tool. How confident or optimistic are you that essentially humans have got what it takes to essentially make the transition here that many people are worried about? To what extent, the world of 2018 here and the issues around how do we globalize, how do we solve climate change, how do we come to live with machines, how do we deal with inequalities? I mean, all these big challenges and kind of sub-challenges under that. How do we deal with, genetic engineering and making the rules for that? And how are we actually going to understand with life extension? And how do we deal with that? And how do we, anyhow, all this different issues. When you step back, what do you think we're up to the task here? Do you think it's and if so, why?
I do believe we're up to the task. I am confident about this because humans inherently want to socialize and share information. That's been selected for evolutionarily. People who work in teams and collaborate were much more likely to survive 100,000 years ago than the lone wolf equivalent working by him or herself, right? So the idea of collaboration has been a directed force in evolution. It's been selected for over time under challenging environmental conditions. And that's the same set of attributes that we'll use now to solve a lot of these problems. Mm-hmm. So the challenge we have is we need to use the knowledge that we already have, and we're drowning in information. And some of that information is being removed as well. So for example, the current administration removed a lot of climate change data from
the Trump administration in the US. Yeah.
Yes, the Environmental Protection Agency's data, and even on the Department of Energy, they wanted a list of all scientists who were working in the field, and the DOE refused to give that list to the administration because they feared they were about to be fired, right? Mm-hmm. So this idea of like removing information and removing expertise to put forth a political view, any view, on the left, on the right, in the center, somewhere else. We're not partisan, but we don't like the idea of knowledge being removed as a strategy for pushing a particular policy point. We view knowledge being embraced and integrated and connected and respected from many different sources as a much more sound way to proceed with policy, with law, with technology strategy. So rather than have our heads stuck in the sand and just hope for the best, we need to be actually looking outward and towards each other and embracing the complexity that's around us. And part of the way to embrace that complexity is to integrate it at a human scale. Mm-hmm. And that's what we're trying to do with Augmented.
So if you looked out 5, 10 years, I don't know, let's say 10 years, and maybe even 20 years. Mm-hmm. Do you anticipate that the future here, near future, that we will have essentially integrated knowledge, interconnected knowledge, instantaneous access to truly most data, accelerated innovation going on in all kinds of different fields? I mean, is that something that you envision is closer than we would think on that? Or now, because you see the challenges and how little is connected, and you see all the challenges we have to get over. But I'm just curious, what will be the state of kind of the knowledge sphere and knowledge workers kind of day-to-day go-to tools in 10, 20 years?
It's a great question, and of course I can't predict the future, but what I can definitely do is say we need to integrate towards that future social and technological engineering. The social engineering is having people from different fields talk to each other. That 200 million person dinner party, for example, which is obviously physically impractical, but which a computer can mediate at scale. So having 200 million author feeds, for example, and having a computer say, where are the kindred spirits here? That is something that's very doable today with today's technology and something we're doing within Augmented. And so that is one example of how this has to happen, but there also has to be a sociological shift. And people have to respect each other from one silo to another. And one of the insidious drawbacks of tribalism is that by definition they create an us versus them mentality. And in those us versus them mentalities, people generally don't cross the bridge or open the door to the other side. They just view them as aliens, foreign invaders into their domain, or heretics to their central dogma. So I've seen evidence of when this breaks down, tremendous advances were made. And I'll give one example. So I got my PhD from Stanford in the medical school in the biochemistry department. And in the era that I was there, in the very earliest years, the housing for that department was just awful. There was no space. The hallways were narrow. It was hard to get from one place to the other without turning your body. And if someone had a bunch of stuff in their hands, it was even harder, right? The lab space was small and constrained, and the growth of the department was huge. So what happened? Two things happened. First of all, people mixed all the time because they had to. And when someone graduated and left the department, generally that space in that lab was not occupied by a member of that lab. It was from some other lab. So people did kind of horse trading. Oh, I'll take her for 2 years in this space if you'll take him for 3 years in that space. And so what happened, I think this was purely by chance, is that there was massive mixing in the department, and people from different areas, subdomains of biology, were talking to each other because they were literally eating lunch next to each other every day at their lab bench. Okay? So what I saw at a personal level was reflected in the 1970s. I was a very young person in the 1970s, but in that department, they invented genetic engineering. And how do they do that? They did that because there were people that were mechanical engineers sitting next to people who were geneticists. And the geneticist would say, I've got this piece of DNA and I'm trying to figure out what it does. The mechanical engineer would say, is that basically like a rope? Could we just cut it and paste it? And the genetic engineer would say, well, there's scissors, molecular scissors coming from the immune systems of bacteria. They're called restriction enzymes. They sense a certain DNA sequence and they cut it. And that's the way bacteria say to a virus, you shall not pass, quote someone else. But if that was repurposed into a way to cut and paste DNA, there are other enzymes called ligases, which are basically molecular glue that'll stick sequences together. So the guy who was the mechanical engineer said, well, couldn't we use restriction enzymes and ligases to cut and paste DNA that have sequence specificity? And the geneticist is like, maybe that would work. And it did, and it created all of genetic engineering, but what it was driven by was cramped space and forced interaction of people from different fields. So some of this is social engineering. How can we construct situations where we have the metaphorical equivalent of cramped space or mixed people that would never normally interact with each other? That's one of the things I hope to do with you. Find a way to mix people from different fields that would not normally think of themselves as, a geneticist might not think of him or herself as a constitutional law person, and the constitutional lawyer might not think of themselves as a geneticist. But to tackle genomic privacy, there have to be conversations between people who would never normally interact with each other. One of the most interesting recent talks I've heard is from your organization for the Stewart Brand interview. And what I found most remarkable about Stuart Brand, I mean, I've known him for about 20 years now, but I didn't understand, especially in his earliest days, just how bold he was. And what he would do that few others would is use his self-agency to call anybody, anyone in the world, Ansel Adams, you know, the governor of California, Jacques Cousteau, right, an astronaut. You know, he was, I think, a prototype, and is a prototype connector.
Yeah.
And if we had a lot of Stuart Brands in the world would be a better place, because the connections that we need to be bold. They need to be, and you can't be afraid to contact somebody because you feel you're not qualified, or you know, you're not in their inner circle. People need to be extroverted when they would tend to be introverted. That's the danger. You know, if we have more and more folks, we have more and more tribes, and we have more and more tribalism because of that. So we've got to break down the tribalism. That is hard. It's not about technology, it's about our brain. If we have this 150 person limit, with a 150 person limit, how do we expand that to 200 million, right? And I think that computer mediation is one way to do that. It's a hack into our introversion, and it's a hack into our limited social memory. And if we can transcend those constraints, which I think computers can do well, we have the capacity to interconnect knowledge at an unprecedented scale.
Which will drive a ton more innovation. Which could solve these
all
challenges
over the world.
Which brings us together.
Yeah.
Well, this is a great place to end, and but you are singing our song here, because at reInvent, you know, really, it's been driven, the foundation of this company and everything we do is it's really connecting people from diverse fields. Innovators, you have to have innovative brains kind of to start with, or at least it makes it a lot easier, and then you connect those innovators from different fields, and that's really, that conversation, those kind of interactions is where the innovation comes. And there's really not a lot other ways to innovate when you really get down to it. There's no like trick tool, or there's no some kind of business model that someone figured out one time. I mean, it's like to continuously drive innovation. You just got to get smart, knowledgeable, innovative people from different fields, focused on different complex challenges, and just keep them at it, keep them at it, keep them at it. And the other thing I think, which is kind of comparable to our mission and your guys' mission, is to make that available. It's like if it all happened in, you know, in some closed room, those 6 amazing folks from different fields talking, that's one thing, because you've at least connected those 6. But what you got to do is figure out ways that you open those conversations up, make those connections available, let other people run with those ideas. And that's kind of what our mission is. And again, it kind of fits into your guys' mission too, which is you're trying to even take that, scaling it on steroids, and just really create those connections, create those conversations more serendipitously, and just more decentralized kind of bottom-up way, and let things go. So
absolutely. I have a chemistry metaphor for us to what you just said. There's this idea in chemistry of a supersaturated solution, like of sugar or salt or something like that. So in this bottle, it may look like liquid, but it's filled with chemicals that just need a little nudge to form a solid crystal. And you put a little droplet of more chemical into that mix, and it seeds a crystal, and the entire structure changes. So you can go on YouTube or what have you and type in supersaturated solution. You can see this droplet effect create massive structure. So it's a seed that creates a nucleation site for crystal growth. That's the way I think of what you just said about knowledge. I think we are in a knowledge equivalent of a supersaturated solution. And all we need is that droplet to create this transformation. So the jobs that you have and we have are to enable that nucleation process to happen as rapidly and as completely as possible.
For a future conversation. For this one, though, it's been a fascinating conversation with Brian Sager on just really the incredible moment we're in right here, the huge challenges, but the incredible opportunities to connect up knowledge workers, to connect up all of human knowledge ultimately, and to actually drive an insane amount of innovation in many directions. So thank you, Brian, for being with us here.
Thank you. Appreciate the time.